Alright guys, welcome back to another Math Notes. This is 6.3.1, Systems of Linear Equations. We could probably also call this solving by graphing. And what we're going to talk about in this section is just that when you have a set of any linear equations or nonlinear equations, the solution or solutions to those system or to that system is where those lines cross each other. So they start us off with a little definition here. A system of linear equations is a set of two or more linear equations that are given together, such as the example at the right. To represent a system of equations graphically, you can simply graph each of the equations on the same axis. The lines may or may not have a point of intersection. The example to the right has a point of intersection which is circled. If you used a method like we had done in past math notes, such as the equal value method, since these are both equal to y, we could say 2x equals negative 3x plus 5. We could add 3x to both sides. Get 5x equals 5, x equals 1. And we could take that and plug it back into our original equation here and say that y equals 2 times 1, which is 2. That method would have told us that x equals 1 and y equals 2. Well, you can see when we graph it that these intersect at x is 1, y is 2. So that gives us the point of intersection for these two lines. You also notice that the point of intersection lies on both graphs in the systems of equations. This means that one point of the intersection is a solution to both equations. For example, the point of intersection in the two lines graphed above is 1, 2. This point of intersection makes both equations true. So here they've gone in and plugged 2 for y, 1 for x. You end up with a true statement there. So that's a valid solution. And we do the same thing here. We plug in 2 for y, 1 for x. When we solve it out, we end up with another true statement there. 2 equals 2. So that's also a valid solution. Interestingly, when you have two linear equations, you have three possibilities, all right, for the number of solutions. The most common is just one solution. That happens whenever you have any two non-parallel, non-identical lines. They cross at one point. You also can have a situation where you have zero solutions. That happens when you get two lines that are parallel to each other. That means they have the same slope, delta y, delta x. Same slope. And because they have the same slope and they're not on top of each other, they never cross. And since a solution is where the lines cross, this has zero solution. The other possibility is a system with infinite solutions, where you may think you have two lines, but once you actually sort of dig in a little deeper, you realize that actually it's the same line, just written in two different ways. And if one line is on top of the other, then it has infinite solution because it touches at infinite points. Right? It touches here, 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 it touches everywhere all the way down the line, so it has infinite solutions. So along those lines, guys, I want you to take a look at the next problem, graph those out, find the solution to the system, or tell me if it has no solutions or infinite solutions. So have that ready for class next time, guys. See you then.